Sorting colors. Given an array nums with n objects that are colored red, white, or blue, sort them in place so that objects of the same color are adjacent with colors in order of red, white, and blue. And then you throw all that color stuff away. Okay, it's an array of zeros, ones, and twos. And they want you to solve the problem without using the library's sort function. Now, first things first, of course, LeetCode's not going to check if you're using an illegal function, and you could just use sort and it'll work fine. Sort nums begin, nums end, and then go ahead and run it. Oh, I didn't want to submit. Go back. All right. So that aside, how do we actually do this? There are two initial approaches that I think are worth talking about that don't end up being the optimal solution. The first is, okay, how do you do this in constant space? Because that's what's required to be considered like in place. The first is you can observe, okay, there's only 3 values. Doesn't matter how long the array is. There's at most 3 different values it could be. So what you can do is count them and then overwrite the array using those counts to get the correct numbers. And that would be a 2-pass solution because you have to go through and then count, and then you have to go through and write. That would be in place, that'd be constant space. It'd be linear time, but it's 2 passes. And then this is saying down here, oh, we think there's a 1-pass solution you could do. So asymptotically, the counting solution, that fits our bill. That's as good as it's gonna get. You're not gonna do a sorting in, well, normally with arbitrary items, you can't do sorting in less than n log n time, unless you get into something like bucket sort or something where you start using some assumptions about the data to do it in linear time. And in this case, we can use assumptions about the data, the fact that there's only 3 items, to do it in linear time. But that's 2-pass. The other thing that I was starting down the road of doing was, what was it? I'm drawing a blank. Oh, quicksort, right. Quicksort is obviously, it's a quintessential algorithm. It's recursive. It's still kind of considered in place. And that one's good to know, but realistically, I don't know that quicksort's ever like super adaptable. It it depends. And quicksort also has a worst case runtime of quadratic, even though its average case is n log n. But we already talked about a solution that has linear runtime using assumptions, so that will beat something like quicksort. But quicksort would be in place. The real solution for this ends up being something. It's also the fact that there's only 3 items. It's not that it's specific, because counting would work if it's like 5 items or 4 items or 22 items or some constant number of values. There's one, you can do it in 1 pass, given that there's only 3 distinct things. And the reason they're using these like color references, which is kind of weird, but they're hinting very strongly at something called the Dutch national flag problem. Now, I don't know why it's called Dutch, because there's like 100 countries that have a tricolor flag with 3 stripes on it. Russia has it. Mexico has it. There's like a bunch of Germany has it. So many countries have just like 3 stripes, and it's 3 different colors. But the Dutch have claimed this as their own, as they do. They have colonized this algorithm. Anyway, so let's talk about what the Dutch national flag algorithm is. It's a 2-pointer solution at its core. It's 2-pointer. There's like a 3rd pointer in the middle that you do some like swapping with, but it's the core of it is 2-pointers. So you're gonna need some pointers. So I'm gonna do with indexes. So int high, low equals 0, and then high equals, I'm gonna set it to the right side of the array. So nums, not nums, nums dot size, so size minus 1. I'm going to add some spaces, make that easier to read. Sometimes I get real bothered by functions that don't use space bars. It's like, good lord. And then the other thing we're going to need to do is figure out something in the middle, because it's not just 2 items, it's 3. So we're going to use a third pointer. I'm going to call it, I don't know, mid. What do we need to set that to? So to start off with, we have no idea the distributions. All we know is that there should probably be the first item should probably be, a 0 after our first swap, and the right one should probably be a 2 after its first swap. And we don't necessarily know what the middle item would be, but if we make sure it's not 0 or 2, it's going to be a 1 by the end. So what I'm going to do is initialize it to 0 as well. You could initialize it to be equal to high and start from the right side, and that would also work perfectly fine. It just flips the order of your loop. So what does we do with this loop? It's a 2-pointer, so that suggests you're probably going to loop while the low pointer and the high pointer are different. And in fact, since the way this convention is going to set up, it's going to be, so to start out, we don't know that the left side is actually a 0. We know that index 0, but we don't know the color is 0. So we only know it's a 0 after the swap. So what that means is we're going to end up doing like one additional swap at the end, potentially. And then once the low and the high cross, so if they're equal, it's not good enough, they have to pass each other. That's when you get into being done. What are we actually comparing? So there's going to be an if. Basically, we're comparing everything against the middle pointer. If the middle, so the middle starting off at the left, if the middle is, if the middle is a 0, we want it to be accounted for by the left pointer. So the left pointer is always going to be just to the right of the last 0, and the high pointer is always going to be just to the left of the last 2. So in order to make that happen, we're going to check this mid pointer, because that one's going to potentially, it's going to go, the left and high pointers are going to increment, but we need to move this middle pointer as well, because that's going to grow with the size of the chunk of ones, however many those are. So that middle color. So if nums mid is, I'm going to compare it to, I guess, the 0 first. So see if the number should actually be to the left of the low pointer instead of being considered part. So we're starting with one big middle stripe of what would be the white color, so ones, and then we're continuously checking. So if it should be red, which is the 0s, we'll swap. If nums is 0, then we're going to swap it. So that would be nums mid equals nums low. And then we know it's 0, so we don't need a temporary variable. We could just set nums low to 0. So nums low equals 0. And then we increment the pointers. So mid plus plus. And in the same line, okay, I'll do it on a different line. Mid and then low. Increment those. Else if. And then we'll do the same thing. Repeat this for the other, comparing mid against the high color. Nums mid equals 2. If it should be on the right side of the array, then we're going to swap those. So nums mid equals nums high, and then nums high is 2. Yeah, again, don't need a temporary variable because we know nums high is supposed to be 2 because we just checked. We just checked right there that we know about that the value in that is 2. And then move the pointers. So in this case, still moving the mid to the right, but then we're going to decrement the high pointer. So high, minus, minus. And then last but not least, we know that the mid value is in fact in the right place. So we still need to increment the pointer. Because our exit condition it's when these cross. Actually, it should be, I think it should be this. I'll double check when I step through the example. And then it's in place, so there's nothing to return, and that's pretty much it. So I'll write out the runtime and then do that example. Won't tease you for too long. All right, it's O of n time and O of 1 space, which is the goal. The time complexity is because we got this while thing, and on every iteration of the while loop, this mid pointer is incrementing in every single one. So actually, I could move that out here. And then I can remove this condition. I can remove that. I can remove that. Yeah. Okay. And all right, so in this case, I think that'll, okay. That's a swap, that's constant. This is constant check, this is constant check. And then we're incrementing this every single time, and we're either incrementing or decrementing this. So we're actually shrinking the window by 2 every step, which gives us an n over 2 runtime, which washes out when you write out the asymptotic notation. So you get that linear runtime. Example. Let's do, I guess we'll do the big one. Let's do that example right there. Okay. So I'm gonna do dots, I guess. So the dot, dot, and then there's 2 dots. All right, start out the loop. Got that initialized while this dot is not there. Okay, if the mid is 0, it is not 0. And then, but the mid is 2. So we're gonna swap. So we're gonna set this to 0. And we're gonna set this to 2. Swap it. And then we're gonna move that down. And then lastly, we're gonna move this over. Next iteration, mid is not 2, or it's not 0. Sorry, it is 0. It's 0. It is. So we're gonna, in this case, we're gonna swap. Yeah, we're gonna swap 0 and 0. I'm not gonna write that out. Just know that they're swapped. So mid is low, yeah, and then low is 0, and then increment the low pointer. And then lastly, increment the mid pointer. Oh my gosh. Okay, next iteration. Mid is not 0, it is 2. So we're going to swap 2 and 1. So mid of this goes to 1, and then this we set to 2. And then we decrement the high pointer, and we lastly increment the mid pointer. Oh my gosh. What did I erase? Good Lord, what did I do? 2. So, okay, this becomes 1. This becomes 2. And then we move this pointer. And we move that pointer. We've already got our sorted thing, but just to check one more time, because we do that until they're past each other, but right now they're equal. So mid is not 0, mid is not 2, it is 1. So we're going to increment that pointer and put it past over there. And then that's our exit condition. So we break, return. Okay, This feels like an incomplete test case because when I was trying this, it failed if I didn't have this condition. Actually, I'll go ahead and remove that and show you. It is necessary. Yeah, see, yeah, it's tested by this example specifically, so that I think is worth running through. Alrighty, so input. Start off with there, our left and mid pointers there, and our right pointer there. Okay, first iteration. Is the mid equal to 0? It is not. Mid is equal to 2, so we're going to swap 2 and 1. So this becomes 1, this becomes 2. We move the mid pointer, and we move the high pointer. Next iteration, mid is equal to 0, so we're going to swap mid and low. So mid becomes 1, and then low becomes 0. And then we move this pointer, and then we move this pointer. So that was our mid. Notice that it took us 2 iterations. That was our mid pointer we just moved because we'd already swapped the high pointer once, so that was down to mid. And now mid is past, mid is there. That's mid. This is high. So that's our exit condition. We break and then return void. Yeah, so that's our example. I'm going to go ahead and submit this now and call it done. Hopefully. Fingers crossed. No, what'd I do? 0, 1, 2. Yeah, okay. Let's see. Didn't I just run through these? What gives? Did it not register? I'm gonna try something. So else we increment mid, but then we don't increment mid when the high pointer changes. Huh. How did I miss that? Anyway, I'm gonna mark that off and think about if I want to re-record or not. Split colors. All right, you guys have a good night.